Assalamu alaikum wa rahmatullah and good afternoon to all of our beloved viewers to the Voice of the Cape's YouTube page and the VOC's Facebook page. My name is Amir Adams and it gives me great honor and privilege to be engaging with our esteemed facilitators as we continue the Voice of the Cape's online matric revision program for this year 2024. This is the Voice of the Cape's online matric revision program, and this is proudly being sponsored by the Two Oceans Graduate Institute, which is an accredited online platform where you can become a primary school or a high school teacher by studying in the privacy of your own home. If you'd like to find out more information, you may visit their website www.togi.ac.za. For today, Alhamdulillah, we have none other than our very esteemed Mr. Ridwan Basir, who will be facilitating today's matric revision session, and he will be going through content for EGD, Engineering, Graphics and Design. Alhamdulillah, as a benefit to all of those students who are watching Mr. Basir's sessions, if you'd like to find out more information or you'd like to find out information pertaining to the previous sessions and you'd like to view that, you may just go onto the VOC's Facebook page or YouTube page and you will see all the previous sessions, not only of Mr. Basir, but of all of the various subjects as you continue to prepare and study for your upcoming NSC examinations. And of course, as our matriculants are embarking upon their NSC examinations, we wish you everything of the very best, and we hope that you will have all the success in managing your study time and that you will be successful in passing your NSC exam period. Without further ado, we immediately hand over to our facilitator for today's matric revision session, of course, dedicated to all the EGD students out there, and that is none other than Mr. Ridwan Basir, who will facilitate today's session, inshallah, on engineering, graphics and design. All yours, sir.
Shukran, Amir. Shukran for being here. Greetings to all the grade 12s. By now you have written paper 1. That's out of the way. So our full attention now is on paper 2, which is the mechanical paper. And last week we had a discussion about CAMs, loci CAMs, which is the question number 2. The week before that we had the analytical mechanical question that we dealt with. So we're going to continue this week with loci CAMs and mechanisms as a combination. Because last week we only did CAMs should the department ask you just a CAM. So we did a full CAM. This week, however, we're going to be looking at a combination of a CAM and a mechanism, and just a way how the department can ask a combination of two. So that is where we are at this very moment. We have 2 more sessions after this particular one, which we will do probably next week, so that we have a full picture of the entire paper 2. And without any further ado, I'm going to share my screen with regard to the preparation activity which I have for today. So just to present my file. So if you are going to view the following, which is CAMs. Hold on, I just want to get my file quickly. So my video file. And yeah, here we go. So just to share that file with you so that you can see exactly what we are going to be doing today. So this is from one of the question papers that we have. And you will see here in the session, we have sort of a combination of a CAM here on the one side, and later on we're going to have a mechanism on top. Now, just before we go to those, maybe I should just share the instructions with you. So the instructions would be then, if I just draw that instructions for you up very quickly, just share my screen again. So here we have the instructions. So as you can see there, this is basically half a CAM that's been shown, and that the CAM follower is now lying horizontal with 0 there and your 360 there. And you're going to find that it has gone halfway as a profile from the designated cam displacement graph. So if you just analyze what we have here, you will see from 0 to 45, which is in between 30 and 60, the cam basically has not moved up or down. So it becomes stationary. So it is at rest, as they call it. Then the cam jumped from 45 to midway between 90 and 120, which is right here. And that was the distance which you see the jump taking place there. And then it dwells, it becomes stations again for another 30, from in between here to in between there. That's a 30 because we have 15 and 15, which makes it a 30. And then it rises further, or as we have it in this case, it goes to its maximum by that amount there to its highest level, which is your maximum displacement. And that would be exactly halfway, 180 degrees. So what you see here, grade 12s, is a wedge-shaped follower, and the cam shaft as well as the first 180 degrees of the cam profile and the displacement graph in the correct position. So we're going to leave the motions and we're going to go to the instructions. As you see it here, you need to use a rotational scale of 10 millimeters equals to 30, and that is what we have here. For every 30, that distance from here to here is 10, 20, 30, 40, 50, 60. And then you obviously have a scale of 1:1 on top here. And then you need to label the displacement graph and include the rotational scale. So it's important for you to label the graph here, cam displacement graph, and the scale of 30 equals to 10. And for that, you get 2 marks. And then you need to project and complete the cam profile from the completed cam displacement graph and all the motions. And then you need to indicate the rotational direction with an arrow. And in this case, it's going to go in an anti-clockwise direction. And then furthermore, you need to show all the necessary constructions and projections. So all the faint lines of how you got it need to be there. Okay, so that's basically how the marking allocation looks for the graph construction, plotting of graph cam construction, cam plus cam curve as well, the quality of that. I'm going to stop this sharing and I'm just going to go specifically to my video, which I'm going to present to you. So if you look at the activity that we are going to be dealing with, as we've read the instructions, you will see that I'm firstly going to label it, and there I'm drawing 2 lines. You don't have to draw 2 lines. You can simply just print it neatly underneath the graph, and that would be your cam displacement graph. And you're going to have your scale of 30 degrees equals to 10 millimeters. And that's very important to write down below every cam displacement graph, because that will be that each of these will have a 1 mark allocation, which you will get. And that's like very easy marks for you to obtain. Then I'm going to then construct the rest of the graph, which is another 180 degrees to this side, and you will see clearly by doing so. I am just going to take my compass, open it up at one of the gaps, which is literally 10 millimeters according to the scale, and just have 6 even parts marked off. I'm now going to follow the same process as we have here in our given by drawing lines faintly up till the maximum. And of course, I'm just doing it faintly because it's construction. And then there I have my 6 parts. And then, of course, this is my maximum that you will see here. So what I like to do is just to give sort of volume to my displacement, my graph, my profile, and that is where my maximum is. and my minimum is going to be where the tip of my cam follow is. And that's my divisions that I have. And because I've got 6 vertical positions here, it must match the 6 vertical positions here. So I'm only going to do it this side. I don't need to do it this side because that's completed. And that reflects on this half here. And then I'm going to label it like I normally should with the 210, 240, 270, 300, 330, and 360. And in the same vein, I do it on my rotational section of my cam, which is where my cam profile is going to be 210, 240, 270, 300, 330, and 360 is exactly where 0 is going to be. As I mentioned, you have a maximum, and the tip, between the tip of the follower and the center, that is going to be your minimum radius. So this is your minimum radius, that's your maximum radius. So everything is going to be in this space, and there I indicate with my arrow, it's an counterclockwise rotation. Now I'm going to focus on this, right? And it says clearly that it is now going to dwell for 45, right? So we are there at the moment. So it dwells for 45, and this is what the motion state. So it dwells for 45, and 45 is now going to be 30, and halfway between 210 and 240. So they have indicated that dwell period. Then, learners, it says further in my motions, and I'm reading from my motions, which you can't see. For the next 90, so you got to count 90. So 3 30s, 3 units of 30s. It's going to drop from there to its minimum, from the maximum to its minimum over a period of 90 degrees. But because we are halfway here, you got to work now a full on 90 inside here. So that's 15. And then we have this 30 here and another 30. So you got to go halfway here of the third one to bring in the 90. Now you will see that I'm actually dividing that halfway to bring in my 90. So what you see here from this line to that middle is going to be 90. 15 and 15 on both sides here gives me 30, and the 30 and the 30 here will give me the 90. So that's going to be halfway between 300 and 330. So it's going to drop down directly from here to there. But the motion that it's going to drop is going to be simple harmonic. It's going to be simple harmonic. So we're going to do a simple harmonic motion. And you know that the simple harmonic motion has where you need to draw a semicircle. You need to draw a semicircle. And the semicircle, obviously, which you will see in a moment, has 6 parts, which are the horizontal 6 parts. So what you need to do here is also to convert the 90 into 6 parts. So I'm going to use 15 because I have 30, and 15 and 15, which is going to now amount to halfway of my 10, which is 5. So if you look at what I'm doing is that I'm going to divide this 3 units into 6. And by doing so, I divide each of the blocks of 10 by half, which is 5. So just to pause there, so you will see here 1 of 15, another one of 15, another one of 15, that's 3, 4, 5, 6. So it's going to end right here. So you have 6 vertical section divisions. It has to be 6 because if you are going to draw your semicircle, and your semicircle is going to be where it ends. So what you need to do to be able to draw your semicircle is you need to take from the minimum to the maximum the distance divided by 2 so that you have a center point, and use your compass to draw a semicircle. So that is what I'm doing. And in this case, it is 54, and 27 is my midpoint. And now I'm going to simply just take my compass, and I'm going to use my compass to swing a semicircle. And that semicircle is going to be, that is the point where it's going to drop to, down to, which is my point. So there's my semicircle. I will now divide it and draw a line across. That's my middle line, right? That's my middle line. And then I'm going to use my set square, 30 and 60, to divide into 6 different parts of my semicircle. And they have done the divisions. These are the points on this half circumference. And then I'm going to just project those points across, which you have done obviously many times before in your classroom activities. So there you will see, grade 12, I will have 1, 2, 3, 4, 5, 6 horizontal spaces, and it matches my 1, 2, 3, 4, 5, 6 vertical spaces. And you will see now, I will now simply plot one down, and move my way further, my plotted points till the end, till my drop. Draw a faint line through it to get a nice and even shaped line going through all the plotted points. And then, of course, you can darken that, making it a nice smooth curve. Simple harmonic is this construction that we have there. And then the last one, it dwells for the last 45, which is midway between 30 and 330 and the 360. That's the first part. The graph is now done. Now we're going to take the linear motions onto my rotary motion. So you will see here, I've taken 2 points, which are now dwelling, which is on my 270 and midway here. So it's going to be midway between 240 and 210. So look what I have to do now to be able to get that point here. I've got to divide that angle here, this angle here, which is 30 degrees, into 2, which is 15. So I simply do that construction on each side, and I'm going to do it in all of those because I'm going to have those little sections, those divisions here as well. So I do that, and if you can't do it on the outside, nothing prevents you from doing it on the inside as well. So there I do my divisions. As you can see there, each one perfectly divided in half. And now, learners, I can easily plot my point. That is my point. It's still on the outside, and then it drops. So you take it onto your center line, and then you project it. You project it from that center line to this specific point, which is going to be this point of 240. So that's where my plotted point is going to be. And then I'm going to drop to the next point, which is midway between my 240 and my 270, which is going to be this line over here. Project it across onto my center line, and then transfer that point onto this point over here by anchoring it in my center. You can see a slight little arc. There it is, plotted point. Now I'm going to drop down to my midpoint here, which is perfectly on my 270. And that's going to be just straight on this line here. So that point that you see there is the actual 270 point, which you're going to plot there. And then it drops down further to this point over here, which is midway between 270 and 360, which is going to be this line. And then you just transfer that point onto this line. And you get marks for all these lines that you show the transfer of the points. You get marks for it. And then you drop down to the next point, which is going to be your 300. So the 300 is going to be there. You're going to take it over, strike it onto the center line, and just transfer that over to the 300 marker on your rotational part of your cam. So there I transfer it over, and I'm going to plot my point there. And then my lowest point, which is in between 300 and 330, is basically on this circle here. It's on this circle here, so it's going to simply be there. It's on the circle on my minimum, because it's at my minimum here, so it will be on my minimum there, right? But you obviously need to halve that space as well, which I'm doing right at this moment. There you will see I halve that space on the inside. There it is. And then I'm going to draw a line. And exactly at that very point here. That is where my plotted point is going to be at its minimum. And then you will just have the two other points that are now stationary as well, which are dwelling. And there you have all your points. And you can simply just now take a line and connect all the points faintly first, making sure that there's a nice curve and a flow of the cam profile. And once you know that you have that line, you can go over it nice and dark, because you do get marks for how you draw the curve. Okay, so that's the one part of the question that we have, and we're just going to pause it there. I'm simply just going to go to the second part of my question, and I just want to go to the instruction page. Let me just share very quickly the page that first I probably need to just stop this quickly, right? And then I'm going to just share that with you, instructions. Just a moment, navigate my way through my slides here. Here we go. So guys, if I go to my next one, right? This is mechanisms. So here you will see that, and I want to read to you what is given. A simple schematic diagram of a mechanism consisting of crank AB. Now you'll see here, there's crank AB. That is crank AB. This is not a wheel. It shows a motion. So that's a crank. It's like a pole, AB. It's on an angle of 60 degrees. Right? Connecting with rod BC. Now there's a rod BC. So that's a rod. That's a crank. A crank means it swings around that center point there. It swings around that center point there. So then further connecting to rod CD. There's another rod here. CD. And you have another crank DE, which is here. So A and E, they are fixed points. They are fixed points and they rotate. But they are rods that are connected to each one. You will see this swings around that way in an anti-clockwise direction. And then that goes in a clockwise direction. There's a certain movement that takes place when it goes into that sort of motion. Right? The position of point A also on the drawing has been given to you. There it is. So you're going to make sure that you know where point A is. And then if you look at the specifications, the position of A and E are fixed. So with those, A and E are fixed, and that swings around. Connecting rod BC is pin jointed or pin joint to crank AB. So these are joint with crank AB, which is that there at that point. And then connecting rod CD is pin joined to connecting rod BC. So that one is connected there and this one is connected there. Connecting rod CD is pin joined at crank D at DE. Connecting rod CD is pin joined to crank DE at D. So there it is connected to that rod D. Okay, so you need to understand that all of these are connected and they work sort of as a team, as a connecting mechanism. The motions as the crank AB, which is that one, the main crank, rotates in an anti-clockwise direction, which is this way. Crank DE rotates in a clockwise direction. So this one goes this way, that one goes the other way. So you've got to understand what's happening here, how it moves, right? You need to draw to scale 1:1 the given schematic diagram of the mechanism. So you're going to redraw this to scale 1:1 exactly as it is here, starting at point A. And then, like 12, you need to trace the locus generated by point C. Where's point C? That point there, right? for one complete rotation of the two cranks. Just for one rotation. That's what you need to do with mechanism. So there are different mechanisms. You know, I'm just selecting this particular one to give you an idea. But you, of course, you can use many others in your revision program that you have to just explore. This is just one activity from one particular, and there are many from one particular paper, and there are many. So expose yourself to as many as these possible before the exam, just to make sure you understand. But the basics, the concept is basically what I'm trying to explain to you. If you look at it and you read the information, you must be able to understand what is happening here, because this drawing can become very busy. Okay. And if you are stuck with it, at least what you should do is basically maybe just draw the given, because that's the lower order part of the drawing. And if you draw the given, you will surely get marks for those as well. And maybe if you continue, like I'm going to show you now, when I share my, I just want to share my screen in video file. Okay. Just bear with me. I'm just navigating myself through this. Yeah, let's just present. Okay, I'm just gonna just hold on one second. I'm just finding my way around this video again. Grade 12. So here we go. So I'm going to present. It's just taking time to load. There we go. It loads. Okay. For your patience. Thank you for your patience. We've done that already. So I want to go to I want to quickly move there. Okay. So now the first thing that I'm going to do, hold on, that is not my drawing that I want to get to. Let me go to this one over here. Sorry. Okay. Start. Right. Here we go. Okay, just want to bring it to the point where I need to have it. So the first thing that you're going to do here is going to be where you are going to redraw both, or not both, but both cranks. So I start at A. You will see that there I measure my distances away, right? And then I'm going to have my radius of, I think it is 30. And on both of my cranks are 30. Take my compass and then swing very faintly, because it's not a wheel. It is simply just the motions that it's shown. That's shown on the drawing. You know, and obviously, if you have work with circles, it's best to divide the circles into 12 parts, because those give us even sort of intervals that we can actually trace the locus of a particular point. And if you ever see a circle, it's best to divide it into 12. That's your construction. And then I darken that crank there, AB, and I label it. Very important. You get marks for that. And I label this crank, which is DE here. That is going to be dark. So you've got to make sure that that's slightly darker. Okay, that's the first thing you do. And now you're going to take the rods, the sizes of the rods. And the one rod is, as you can see, I'm opening it up here. It is going to be 60, and I take it from there. Here's my one rod, 60. And you will see the other rod is 70, if I'm not mistaken. Yeah. And then where the two cross, and I've arced it from those two specific points, that is basically how my given will look like. Can you see? It's easy. That rod was arc 60. This one was 70. With the two cross, that's where C is going to be. That now forms my two rods connected to my two cranks, AB and DE. Okay, so surely you can do that. If you're going to continue, I would say put down your directions. So, you know, the directions is very important. There you can see I put the numbers down, 60 and 70. And then I'm going to use, in this case, two compasses. The one is going to be opened up at 60, and the other one's going to be opened up at 70. I'm going to use both of them to assist me. And then I'm going to label my direction. So anti-clockwise for this one and clockwise for that one. And then what I'm going to do is to label it according to my clockwise. Now you can see here, because it goes clockwise, I'm going to label it from here. It moves to number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 to this side, and it finishes off there again. And remember, you got to follow. If that goes that way, so now you're going to go clockwise, 1, 2, 3, 4, 5 until 12 here. So it's important for you to go according to the direction. And if you have this one goes this way, that one goes the other way. And all you need to now do is to match number 1 of this one with number 1 of that one. Let's see. You're going to follow a pattern. So the first movement is that way. So I'm going to arc the 60. I think, yeah, 60. And then from this side, the first movement is that way. Both number 1's movement. And I arc and I arc. And look at that. Now I'm going to draw an imaginary line, faint line. Right? There's number 2. Both number 2. The one is 60, one is 70. I arc. There. So what I can do now is to draw imaginary lines like this, so that you can actually see the movement of the 2 points, both sides. Number 1 and number 1, number 2 and number 2, to the point where it crossed. You can see number 2, and you can see I mark it, number 1, number 2. That is now how C now is going to move. Number 3, that side arc, and number 3, that side, wherever it crosses, that is now how you are going to plot your point, and you're tracing it, and your imaginary point again. So you got to pick up a pattern here. What happens? Right? I move to the next number, 4, and then I take both arcs. I arc at both sides, you know, and I'm using 2 of these. Otherwise, if you have 1, you've got to change your settings, you know, to 60 and 70 all the time. It takes a little bit longer. So I'm just doing it faster with both. There you have number 4 and number 4, and they're meeting there, and I'm plotting number 4. Now I go to 5. 5 is there, and 5 from the other side. That's number 5. 6, and you can see my movement. There is 5 and 5. I draw the imaginary lines. Now I go to 6. We're halfway. We're halfway. It moves to 6, and there it moves to 6 on the other side. Both compasses connecting at a specific point, which is right there. Measure numbers, not measure, write down number 6. Very easy. Pick up the pattern. So imaginary line again drawn, so that you can see how the 2 rods actually position when they are positioned, when they go right around. Number 7 and number 7. Arc number 7. You just got to keep track. And because there are so many lines, I label it. I label it so that I can keep track of my movement. This is my imaginary line. So it's 7, 7, 7. Now I go to 8. 8 is there, and I move to 8 on the other side. And you got to just find where the arc is. And the 2 arcs cross, number 8. And then the imaginary movement lines, which I have from 8 to 8. And then what I'm going to do is go to number 9. And you will see that number 9 is going to move an arc right there. It's getting very busy now, a lot of traffic of lines, but I keep track of labeling it. And now I draw my imaginary line. So we're almost done with this particular drawing. And there you will see that we have number 9, and then we go to number 10. Very busy, but you just follow the pattern every time, which I'm doing and labeling it. That's all you need to do. Doesn't matter if there are many lines. You focus on the lines that you are busy with. So now I'm focusing on number 10. Now I'm going to move to number 11, which is literally my last one. There's my last one, and 11 is that side, the last one. And I arc both sides. There's my 11, mark it. The next one would probably be, so just fill in my imaginary line again. There's a lot of lines here, but you're not worried because you have labeled your points from 1 to number 11. And then number 12 obviously is the C that you have there, which you have as a given. And now, all you need to do, I'm doing it in red, but you can't use, the points are very important because you get marked on the points, the correct points. So you got to clearly make sure that you mark the points. And please do not use color. I'm using color for explanation purposes to show you the different points. But you just got to make sure that you have your points. And then all you do, you're going to take a pencil and draw the flow, trace the locus. And that is the tracing of the locus, that faint line. And then you're going to darken that line so that it makes a certain shape. It forms a certain shape. And that there, and I just want to pause quickly, just come back there. And that there, learners, is tracing your locus of point C, how the movement goes for one revolution of 360. Brilliant. But it's all about understanding. Okay, we have time for one more of these mechanisms. Let's take a random example. So what I'm going to do is, let me just stop my screening. Let me just remove this quickly. Just bear with me as my computer loads. Right. So let me share the next activity very, very quickly and just read the instructions. So if you go to the next one, yeah, here we go. If you look at this one, you can see already, it says here that the schematic diagram of a crank AB. Where's AB? There's AB. That's a crank. And a crank just goes around a fixed point. You can see there. Here's like a circle, but it's the movement. It's not actually a circle. And then you have a connecting rod BC and a rocker CD. Now, this is the connecting rod. It's connected to B. And this rocker is fixed here at D. We will see now in this. And the rocker means it goes back and forth. It swings back and forth around this pivot point, back this way and back that way. So let's look at the instruction. A and D are fixed points. So that's a fixed point, D, and A is a fixed point. It doesn't move. So this goes 360 around its own axis, and that rockers. So it oscillates basically from the one side to the other side. It makes a curve. Okay, that's what you need to know. And that's understanding. Motion. As the crank AB rotates in a anti-clockwise direction, the rocker CD oscillates. There's the word, back and forth. So it makes that swing movement. Using the instructions are using the given diagram, trace the locus generated by point C for one revolution. Now, in this case, they actually gave the grade 12s the shape, the drawing already. Should they not give you the drawing and you have to redraw it, this is what you are going to do. Okay, the dimensions will all be given to you. And make sure you just follow the dimensions of how you are going to draw that. Now, in this case, it's there. The first thing that you are going to do. Now, I'm going to stop this because I want to go to sharing my screen again. Just bear with me as it's going to load. It's going to load in a moment. Just give it a few seconds for it to load. Yeah, there we go. There we go. So I'm just going to slide this to, here we go. All right. Mechanism. So there we have our drawing. So what we're going to do firstly is to divide it into the 12 parts so that we have even intervals, 60 and 30 degrees on your set square. And then you obviously need to put it in direction, which is going to be anti-clockwise. So that means your number 1 is going to be there, and it goes according to the clockwise arrow, 10, 11, and then 12. Okay, perfect. Now, you're going to, because this oscillates, you're going to open up a radius of CD, and you're going to just draw an arc to show you how C oscillates around B. And then I'm going to extend that from B to D, right? B to D. Sorry, I'm gonna extend that from B to C, because that's my length of my rod connecting to this rocker here. But the point I need to trace is point P, right? Which is X amount of this distance away from B or from C. And that's they give you. Let's proceed. So now, look what I do. Hold on. You can see that. So there's my opening up. So I'm going to move to number 1, and I'm going to arc onto this arc here. So that is where my C now moves. My imaginary rod there, and there's my rocker. And then that is 63. I think it is 63, and that's where I mark it. That's number 1. So I mark it number 1 in red. You work in pencil. Number 2, I arc it on that there, because this now moves. It pulls the rocker more to the left because it goes from to its furthest end of my circumference. And then 63 on that line. Very easy. And the pattern now follows. Number 2. And then number 3, you cut it off on that oscillation there. Draw the line and where the rocker is at the moment. And you measure from this point here, 63. And you label it number 3. You go to number 4, sharp point on there. It goes back now on here. So you draw your imaginary rod and your rocker there. And then, of course, your 63 again. That's number 4. And then you are going to go with number 5, cut off number 5, draw the line to number 5 and to the fixed point of the rocker. And then you measure off 63. Simple. You follow that process because you understand it now. That's number 5. And then we go to number 6. Now it pushes that rocker more to the right because it's coming to the closest side of, or the right side of my circumference of my motion, which is this side here. And you will see there I connect 6 with that point there and draw down to my base of my rocker. Number 7 is from there to the marked point, and then measured off on the line number 7, which is 63. Number 8 is a way far side. It even goes off here, but what I need to do now is I need to go back, just extend that oscillation there to find that point number. That's number 8 on there. It's number 8, and then 63 again measured. There's my 63. That's number 8. Go to number 9, which is here. It's my 9th point. Open it again to its original size. My 9th point is now going to come back, and it's going to be now almost flat. You will see my rocker is almost flat. There, and it's returning now because it's pulling this to this side now. And then 63 again as my point number 9. And then number 10, I draw the line to number 10, and you will see it duplicates that line of my rocker there. 63 from number 10. And the last one, number 11, you will see there, I cut it off on the oscillation movement, draw the rocker, and then measure from number 11 on the circumference, 63, to have my 11th point, which is my final point. And then obviously that is the 12th point, which is point P. And now I just take a pencil and make a nice even curve with no sharp points, as that I am literally tracing my locus of point P. And once I have that, I'm now going to darken my movement and I'm using green at this point. Please do not use any color. You have to use a normal pencil, right? And by having that standing out in pencil, that is the locus traced by point P on my rod, which I have there. Nice and easy. A certain pattern that was repeated 11 times based on understanding of what needs to be done. Okay, so that basically concludes our session for today, which is a combination of a cam and mechanisms. It possibly could be coming in the exam like that, and if it does, you will be fully prepared for that. And like I said, these are just two of many mechanisms in past papers. I would suggest that you take some of those papers and work through some of these combinations. But I'm really hoping that they could ask an easy one, or maybe just a cam, or something that you will be able to manage and benefit from this session that we have. All the best, guys. 2 more sessions to go. Next week, we will be looking at isometric drawings, and hopefully you will benefit from that session as well. All the best and good luck.